Hello friends, welcome to this video. This is going to be another video on semantic segmentation. Here in this video we are going to use UNET for Polyp segmentation. So before moving forward in this video, make sure that you subscribe the channel and hit that bell icon. So now let's move to this video. So things we are going to learn in this video. First we are going to learn what is a polyp. Next, what is semantic segmentation. Third, our architecture unit. Next is the dataset we are going to use. And fifth point is the project structure. What are the files and the folders in this project? And at the last is the implementation. For the implementation we are going to use the Python 3.8 and TensorFlow 2.0. So first of all the question arises, what is polyp? A polyp is a growth of tissue on the lining of the colon and rectum that projects into the intestines. Some polyps are harmless, but some can develop into cancer. Colon polyp often does not cause symptom. Polyp removal is the best way to treat colon polyp and prevent cancer from developing. Next is, what is semantic segmentation? We need to know what is semantic segmentation, as our the task is only semantic segmentation. So the goal of semantic image segmentation is to label each pixel in an image with a corresponding class. It is also called dense prediction, as we are predicting label for each pixel. That's why it's called dense prediction. Next is our architecture, that is UNET. So you can see a diagram of the UNET. We're going to build a same architecture like this U-shape architecture. So this UNET is a fully convolutional neural network that was developed by Olaf Ronneberger. It was specially developed for the purpose of biomedical image segmentation. So UNET is a base model which is used everywhere. If you want to perform any semantic segmentation task, the first architecture that comes in any mind is the UNET. Next, the dataset we are going to use. So the dataset we are going to use is CVC612. So the dataset contains the image extracted from the colonoscopy videos. These images contain different type of polyps. The dataset also include the ground truth for this video. So you can see a sample image and its corresponding mask in the slide. Next, the project structure. So this project consists of 4 folders. CVC612, that is the dataset folder. It contains the images as well as the mask folder, which within them contain images and mask files. Second is results folder. So this folder is going to store the prediction images, the predicted result on the test dataset. Files contain the weight file and the CSV file and other required file. Log contain the TensorFlow log files. So the project divided into 4 files, 4 Python files. First, data.py. So the data.py is going to handle the data. Model.py, we are going to build the architecture. Train, where the training begins, and prediction, we are going to test the model. So now we will move to the data.py. So now we have move on to the implementation. So first point here is the load the dataset, split it into training, validation and testing dataset. Now let's start programming for it. First of all, I will give you an overview of the dataset. This is the folder CVC612 to contain the data. It has 2 subfolders within the images and mask. So these are the images. So it contains 612 images. This is a sample image, and if I open the mask, so you can see its respective mask. So this is the data we are going to load and split it into train, test and valid. So now let us create a data.py file where we start our coding. First of all, we will import some libraries. First, the operating system. Second is NumPy. So NumPy is one of the most important and fundamental library for any data science related task. You can also use it for mathematical task. Next is globe, and after the globe is the TensorFlow, which is our library for this task. And after that we are going to use the sklearn library and import the train test split. To use this train test split function to split the data set into the train, valid and test. So now we are going to define a function load data. Okay, here we will give it the path Now the split, I say 0.1. So the dataset split is going to be 80, 10 and 10. Oh, I'm sorry. So 80% is training, 10% validation and 10% for testing. So now let's load all path for the image. Join the path. So this path variable contain path for the folder 612. So with this path we will join the images and write a star. I will tell you what why I am writing star here. And same thing which so now we have path for the images and mask. Now let's write globe in front of them so that it can load all the images and mask. Now we have all the images and mask. Now we will sort it so that they are arranged in a sequence. This sequence help them to get correct image and its respective mask. So now we have a list of images and mask. Now we will split them. Let's first calculate the size of the images. Validation size should be integer split into total size. Test size is also going to be same, but still we will write it integer split into. Also what you can do, I just splitting them into 80 10 10. You can split them accordingly according to your requirement. So now let's do one thing. Try to run this small program and see if there is any error. The path is equals to CVC 612. So if you want to download the dataset, the link is given in the description, and check the description where you can find the link for the dataset. Load data path. Okay. Now sprint total size, valid size, test size, and the remaining Python 3.8. okay, invalid syntax. Okay, should be from globe import globe. Okay, I think okay. No module name sklearn, so we don't have any module. We need to install it. Let's install it now. Sklearn. So it takes small amount of time. It doesn't take that much amount of time. So we will run it again and see. Now it will run. So you can see 612 total images, 61 for the validation and 61 for the testing. There's something you need to ignore. It's going to come every time. So what I do is I write a print statement here. If anyone have a solution for this error, this invalid MIT magic, please comment below. It always comes this part. Now let's move to our video, and now we'll split it. Train X. First we'll split the the data into training and validation. Train test split images test size is equals to valid size random state 42. Mask valid y and valid y. So train X valid X contain the images path, and the train Y valid Y contain the mask path. Now again we will copy it and divide the training data into training and testing. So should be train X and test X, train Y, test Y, and here we will replace it with the train images and combine this with the test size. Okay, now we have this data. The return train x, train y, valid x, valid y, test x, test y. Okay, so we have this data here. So we need to check this function for any error. Now we'll print the train x, valid x, and length of test x. And let's run it, check if there is any error. So you can see 490 images for the training, 61 for validation, and 61 for the testing. Okay, now let's again move to the PDF file. Now we'll now next is point 2, read the image and the mask. Now we'll create a function where we will give it the path, and it will read the images and mask from the path and give us a numpy array. Read image path. Okay, I have write this line to decode because the path here is going to be in a binary format which we need to encode it. Okay, I will import the CV2 library here. Open CV. Okay, we need to read it in RGB format. So now we'll resize it to 256 by 256. Now we will normalize the image by dividing it with the maximum pixel value, that is 255. So the value of the return now numpy array is going to be between 0 and 1. So it will help us to converge easily. It will reduce the training time. If we have large values, then loss will also be large, and large loss means it's going to take a very good amount of time, very large time, very big in converging. So again write this function, read the mask. Okay, now the mask is going to be in grayscale. Again resizing it, normalizing it, and now here we need to add one more step because we are reading a grayscale image. So we need to add a dimension into its last axis so that its size became proper. Before that, its size is, let me tell you, 256 by 256. After that, its size became 256 by 256 by 1. Okay, so above here size is 256 by 256 by 3. Okay, so that's the function. Now again moving to the slide. PDF. Third point is setting up tf.data pipeline for training. Now we need to set the dataset pipeline. First, before that, let us use that function and check if there is any problem in this. Let's read an image. Okay, let's check it once only. I know how we can do this. So first, def tf dataset x y. So x is the image paths, a list of image path, y a list of mask path, and badge. By default we given it 8 size. So dataset is equals to tf.data.dataset from tensor slices x comma y. Dataset is equals to dataset dot map. Now we haven't created this function tf parse, we are going to create it. What it does is it this dataset map function give it a single image path and a single mask path. Now it need to read it and give it a numpy array proper value. After that we will start batching with the batch. So they start forming batches of these images and mask numpy array. Dataset is equals to dataset dot repeat. Now returning the dataset. So this is one part, and now we need to write this tf parse function. What it take is x and y, single image and mask path. Now again inside parse a function, take this x and y and return, because we need to return image, mask and path as a set together, not as a set or list, just both thing together. So x is equals to read image x, y is equals to read mask y, return x comma y. So we need to return this in the format x comma y. Now as this function is written in numpy, this read image and read mask function, so we need to convert it in a usable form so that TensorFlow can accept it, can work with it. Numpy for, and to convert this numpy function into TensorFlow usable function, use numpy tf.numpy function parse x comma y tf.float 32, no, float 64 we are going to use, again float 64. Now we are going to set the shape for them. What's going to be the shape of these x and y? For the x it is, I have told you, 256 by 256 by 3, and for y it's going to be 256 by 256 by 1. So that's this whole dataset pipeline which is ready. Now we can just test it. Dataset tf.data set test x test y. Okay, now for x comma y in ds print x dot shape y dot shape. Now let's break it. So here we have used the test x, train x, and batch size is by default 8. Now we have just loop over this ds and just printing the shape of x and y, and let's see if it run without any error. Okay, so there's an error here, and let's see what's the error. Dataset.map. Okay, we haven't written anything here. We need to written x and y here. That's the mistake I've done, I think. Let's see if another error. Okay, so you can see a batch of image and mask, batch of 8 images, size is 256 by 256 by 3, and mask 8 images, 8 mask, 256 by 256 by 1. So that's about the dataset pipeline which we have built now here. So till now we can see we have completed the data.py file, loading the data, splitting it into training, validation and testing. After that we read the image and mask, and after that we set up the pipeline for the training for the dataset. Now let's move to the modal.py file where we have only one single task, building the UNET architecture. So now let's move on to this part of building the dataset, the UNET architecture. Modal.py. Import TensorFlow as TF from TensorFlow.keras.layers import con 2D, then we have batch normalization, activation, we have upsampling, 2D, okay. If we need one, we can add it accordingly. TensorFlow dot Keras dot models import model. Okay, we need one more. I remember input. So now first of all we will define a convolution block, a simple convolution block which take input x and a num filter value. So x is the input, num filter is the number of filter we want to use in the convolutional layer. So x con 2D. So in a unit we have two 3x3 convolution operation which is followed by activation, but before activation we are going to add batch normalization, as batch normalization improves the performance. So we're going to use it. So first of all, num filters 3x3 padding, we're going to keep it same. Batch normalization x, then activation, reload activation. Again same thing we need to follow. We will copy these lines and return x. Now we will build a model. We know size of the input is 256. Num filters is equals to 16. So filters in the unit is from 64, 128, 256, but I'm just reducing accordingly because for this demo we need to keep it short so that it can run and train in this video only, because if you increase the number of filter, trainings and time will also increase, and you need to set them accordingly for your requirement. For my requirement I feel these are sufficient, and later we'll see in the training if we have any problem we'll just change them. Now setting the input layer, its size. So size is 256 by 256 by 3. Now creating an empty list, we will keep the skip connection information. X is equals to input. Now we'll build the encoder part. For f in num filters, x is equals to con xf and skip x dot append x. So we have appended skip connection to the list skip x, and after that we need to perform max pooling here, a 2x2 max pooling. So we need to recall this function above, import this function above, max pool 2D. We haven't imported above. Now this loop goes on. Next is the bottleneck or the bridge. So let's move to the architecture part. So this is the encoder part from here to here, and this is the bridge, and after that this is the decoder part. So we have completed the encoder, now we're in the bridge, and then we will build the decoder. Let's move the code. Bridge, x is equals to con block x num filters -1. So the last filter is going to be applied in the con block. Now we'll build the decoder. Before that we do something. We will reverse numpy filters. We're going to use them in reverse order. In the starting we'll apply 16, 32, 48. Now we will apply it in reverse order. First 64, then 48, 32 and 16. And like this we also need to reverse the skip connection. We just reverse this for our easiness, because it is easy for us. enumerate num filters. Okay. Now first we will start with upsampling layer. So upsampling 2D is not a learn layer, it just copies information from one pixel to those 4 pixels. You can also use con 2D transpose. Con 2D transpose or transpose convolution learns how to upsample the image. Let's extract the skip connection information from this list, and then we will concatenate. We haven't also called the concatenate. Copy this here, concatenate information x and the skip connection s, and they'll add a con block x and filled number of filters f. Now is the output layer, that is final layer, the classifying layer, the classifier of this block. Con 2D 1 number of filter 1, we need one, we have one class 1 by 1. Padding is equals to same input x, and at last we will apply a sigmoid activation, as sigmoid returns a value between 0 and 1, and our mask is also having a value between 0 and 1. So that's why return the model inputs x. Now let's do one thing, run it and check if there is any error. Model is equals to build model dot summary. Now let's run this model. Okay, now the model is built successfully without any problem, and it has a total trainable parameter of I think 4,14,401. Okay, these are total parameter. Trainable is 4,12,865 and non-trainable parameter of 1,536. Okay, so we have also built the model. Now the next part which come is the training. So the first point in training is load the training and validation dataset. So we shall start with the training file, the train.py. Okay. First we will import libraries, and I know what libraries we need. Let's do one thing. Okay, now we need to import some callbacks from TensorFlow. Keras. Early stopping, modal checkpoint, reduce LR on plateau, PLATEAU. Okay, plateau. CSV logger, and at last tensor board. Let's import some function from the files also we have built. From data import load data tf dataset, from model import build model. Okay, now we need to load the data, and actually we have already done this here. We can directly print it, copy it from here. Okay. After that, set up the TF data pipeline for the training and validation. Okay, and after that setting up the hyperparameter. So we'll do both the steps together, setting up hyperparameter, then this TF dataset pipeline. So first we'll write the hyperparameter above, like batch size is going to be 8, learning rate 1e minus 4, epoch 20. Let's say after that the dataset pipeline, training dataset, so train x, train y, batch is equals to batch, valid dataset, TF dataset, valid x, valid y, batch. So we have built this dataset pipeline, and after that building the UNET model, after that defining loss optimizer and matrix. Model is equals to build model. Okay, model is built. Now the optimizer is equals to tf.keras optimizers Adam. We're going to use Adam optimizer with a learning rate of 1e minus 4. Matrix accuracy, let's do one thing, import matrix also here. Recall precision. Okay, now let's build another matrix IOU, y true, y pred. Okay, now defining the function f, which is going to take again these two parameters, y true, y pred. Intersection, so IOU is the intersection over union, so intersection is equals to y true into y pred dot sum, and union is equals to y true dot sum y pred dot sum minus intersection. Okay, now returning the value intersection plus 1e minus 5. So we'll add a little value to both this intersection and union, so that if like union value gets 0, if union get absolute 0, so we will not have any error of division by 0. So we'll add this little value in both. Converting it to float 32, then returning it. So this is our IOU metric numpy function, y true, y pred, and tf dot float 32. Okay, now we have this matrix, recall precision and IOU. Okay, now we will compile the model. Loss binary quotient we are going to use here as the model. We need to binary segmentation. The value is going to be 0 1. Optimizer equals to opt, and metric. Okay, now I compile the model. Next, let's see. Next is defining the callback. So let's define all the callback which we have imported above. Modal checkpoint, files, model.h5. Okay, next, reduce LR on plateau, monitor. So first, modal checkpoint is to save the await file with after every epoch if there is any improvement, and reduce LR on plateau, it just checks in the learning rate if after a specific number of patients, like a specific number of epoch, it will reduce the learning rate by the specific factor. Monitor validation loss factor reduced by 0.1, and patience is 3. If after continuous 3 epochs there is no improvement in the no decrease in the learning loss, I'm sorry, the validation loss doesn't decrease, then the learning rate will be decreased by 0.1. Next is the CSV logger. It just used to save all the training data into a CSV file, which is easy to visualize. Next is TensorBoard. It is only for visualization. TensorBoard is only for visualization. You can visualize all your training, everything, to use it correctly. But I generally prefer CSV logger because now I have raw data. I can do anything with it. Early stopping. So it's used to also have a parameter monitor. We have like validation loss. Patience. Right 5, 10. Restore best weights false. So what this early stopping does is, if for a continuous of 10 epochs the validation loss doesn't decrease, so it will stop the training. This is to just prevent overfitting. If our validation loss stops decreasing and starts increasing, or it is stagnant, this means the model isn't learning anything. And if we continue training in this situation, then model will start overfitting and the performance of our model will get worse over time. So that's why we stop the training. Now let's write the training step. Train steps. Length train x divided by batch size. Batch. Same valid steps length of valid x batch. So this train steps and valid steps define the number of batches. Now if length train x percentile batch size is equals to. Now if we just calculate this is calculate the remainder. If it's not 0, this means anything is remaining, so we need to increment the train step by 1. Now same with the validation step. Valid x, valid step. Okay, so now we have done this. Now start the training. Now we need to start the training. So we'll start the modal fit function. There are a lot of variables. Train dataset validation dataset valid dataset epochs steps per epoch train step validation steps is equals to valid steps, and then at last the callback. Okay, so now the training file is complete. We can start the training and see if there's any problem in this whole line of code. Okay, so we have a problem while importing, and we have done it in an incorrect way. We have corrected. Now let's start again and see for any error or anything. Line number 40. So these errors are just a part of your code. If you don't have any error, this means you haven't tried anything, or you're just perfect. And I think nobody is perfect. Everyone has Okay, again spelling mistake, I know. Here seems like I'm very eager, very fast. Doesn't check. Again unexpected. Okay, it should be validation data. My mistake. Okay, so I can see epoch 1/20. So training, I think training. Okay, training has started. Okay, so training has started. This is good thing for us. So before anything, before start the training, let's seed the environment. Try to make it reproducible. Seeding helps to generate same random number every time. Now do it again and let's see if training start this, then we'll continue with it. Until then we will write our predict.py function. So training has started. Let's see one epoch. Okay, validation loss, validation record, okay, so we have everything. It's also giving us learning rate, I think, side by side, LR. That's good. So let's move to this file, and now we have this predict.py file to write. First load the testing dataset. Okay, this predict.py. We will import a lot of libraries first. Some libraries we can directly import from here. Globe, we don't need it. From TQDM import TQDM is just a progress bar TQDM. Utils, import custom object scope, and from data import load data tf dataset. Okay, now from train import IOU. Okay, next setting up the tf data pipeline. Okay, first of all we need to load the data. Also write the batch size here only. So it's 8. So here we need only test dataset. Test dataset. Test X. Test Y. Batch is equals to batch. Test steps is equals to len test X batch. If len test X person models batch is not equal to 0, increment test steps by 1. Okay, after that let's see. Now load. Okay, I am load and training. Oh, it should be testing. It's incorrect here. Load the train. Oh, so load the training unit mode. Okay, I read it incorrect. Load the training unit mode. and after that make the prediction and saving the result. Okay. Now we'll load the dataset with custom scope object IOU, that's it. Model is equals to tf.keras.models.load model files model.h5. Now we will evaluate the model in a test dataset. Okay, so here you will use it for event. And okay, training is complete. So these 20 epochs are finished really well on time. So what you can do till time, you can increase the epochs again to, let's do 50 this time and start running again and see if there any change, and till time we write a complete code. Now after that what we'll do, we will write some function to save to see what the model is generating and what the real ground truth is for the comparison. And first of all we need to copy some functions from the data, these two functions, the read image and the read mask. We can't import them because we need to make some changes in them. First of all we need to remove this decode. Okay, this is correct. Now it's same here. Now we need not to normalize it. Okay, we have done this. Read image, read mask. Now we need to write the function here. Mask. So this function is required while joining the image, the ground truth and the predicted mask. Okay. Now after here we will start it. For I, x, y in TQDM enumerate, write it simply, enumerate zip test x and test y. Okay. Now I will write TQDM. Total equals to len test x. Okay. Now we build this loop. X is equals to read image, we read the image. Y is equals to read mask. Y. Okay, now we read the image and mask. I will make the prediction. Model.predict np.expand dims x is equals to 0. So now we have this hybrid. Now we have this prediction, the model. What we do is we extract the value from it, y underscore pred 0, and apply threshold value of 0.5. If the value of the any pixel is above 0.5, it's going to be 1, else it's going to be 0. So a proper binary mask. Height, width and channel of the input x dot shape. Okay, Now we need to join all the images. First x multiply by 255 because its value is between 0 and 1. After that mask parse y, that is the ground truth, and the last mask parse, that is y print. Okay, so we have these three images now. Okay, we need to also separate them with some line. So we will build a small white line image of white image, height 10, 3, 255, white line. Now we'll concatenate them. Now concatenate all those images to axis 1 and save it. And results slash I dot png image. Okay, now I think this code is complete. Let's see. Okay, our training is still going. And only 10 epoch left. Okay, so it stops improving, so that's why the early stopping has stopped it. So it stopped nearly improving at 30. So validation loss at 30 is, let's check, 1527. So it stops improving. So the model hasn't given us, I think just is haven't given us good result. It can still improve. So for further improvement, what you can do is apply data augmentation, increase the size of the data set. Accordingly, you can increase the model trainable parameter, increasing the number of filter. You can check the proper image size, also increase it or decrease it further accordingly. Okay, so these are the few steps you can apply on the model, on this entire model or code to improve its result. So now we will run our predict file. Okay, invalid line. Let's check line number 62. Okay, we have this commas missing here. Okay, so this is the result. So losses on the test image is 0.1579, accuracy, the number of matching pixel 0.9584, recall is 72%, precision 84, and IO 40%. Okay, the result is okay, it's not that bad. We haven't trained it much and we haven't tuned it that much. So you need to tune it according to you, because if I tune it and I apply data augmentation here, and so it will take a whole lot of time. Okay, now let's see the images it has predicted. So this is the results folder. Okay, let's do one thing. Let's remove this threshold value and see the value of the original mask. I think I applied much greater threshold. So threshold is also applied accordingly. Or maybe there's any error here. Let me just check if there's any problem. I think there's some problem here in the code, why it's not working correctly. And I know what the error is. I haven't just applied 255 here. The value is between 0 and 1, not between 0 to 255. So divide pixel value is 255. So we multiply. We need to multiply 255. Now we can see the correct result. Okay, now we can start seeing some result. So this result is good. That's it's not that bad. It's before applying the threshold. Now I will apply threshold and you can see the result. So result is good. You can further improve it. Now apply threshold value. You can try it with different threshold value and see the result. The one main thing that will improve the result is the data augmentation. Also you can just change the architecture also, like I am use UNET, you can use REST UNET or deep lab. Okay, now let's see the result. So you can see a clean result. Now the result is much cleaner because we apply threshold value. So you can see the result is good, not that bad, but further it can be improved. So these are all the test results. So I hope you got the understand the how the UNET work and how you can use it for your own data set. Like I have used it for the Polyp segmentation data set, and if you are working on the Polyp segmentation, then this video is really good for you. You can get how to work with this data set. And I can only say that if you like this video and like this content, then please share it with your friend, like this video, and also if there's any problem, I have make any mistake, or there's anything you want to say, just comment it below. And further, before stopping the video, make sure that you subscribe the channel and also hit that bell icon. Thank you. Have a nice day.